All right, so here we are starting word problems that deal with exponents and logarithms. So the first thing you have to understand is what the percent rate of change is. It's just basically the percent that it's being increased or decreasing, or how quickly the exponential is going up or how quickly it's going down. So this is the formula here, and this R is that percent rate of change. So notice inside the base here, 1 is being added to the R. R can be positive, which would make it growth, or it could be negative, being decay. Or you could just add or subtract the rate. So here we are. This is the formula, the general formula for the percent rate of change, for the exponential growth or decay, and how we're going to find that percent rate of change. You have a bunch of different things, P being the principal amount that's out here, that's being multiplied by this power here. R is the percent rate of change, so 1 plus R is how it increases or decreases. T is the amount of time, often it's years, but it can be days, months, hours. It's just an amount of time. And that is the general formula, and we modify it from there, as we go through different kinds of problems. So the first thing that I want you to look at is the percent rate of change. Can you find it just by looking at a formula? So for each of the following, find the percent rate of change to the nearest tenth, and to determine if it is exponential growth or decay. So that's the basic idea. We're going to break apart these formulas and look at all the different pieces. We'll be solving for each of the pieces. And then, it'll be super fun. So how you find the percent rate of change is you take whatever the base is. Okay, so whatever the base is. So this right here is the base, because it's the only thing being raised to the exponent, and you subtract 1. That's it. That's your rate. Because if you look at the formula, it's 1 plus R, so whatever that is minus 1 will be our rate. So 1.025 minus 1 equals 0.025. Now that is the percent in decimal form. So if we actually wanted to write as a percent, it would be 2.5%. So since this is positive, this is a growth problem. Okay, now we know that as long as that base is greater than 1, it will be growth, but finding that percent rate of change, adds that extra piece to it. So same deal here, the base is 0.98. We subtract 1, we get 0.02. Move that over 2, and we get 2.0% to the nearest tenth. Sorry, negative 2.0 to the nearest tenth. So this would be a decay. So as you can see, if you have a negative R, you will have a decaying problem. So here we have this one. So this is in hours here, so it's just different, seeing it different ways. This is the base 2. 2 minus 1 is 1. Move it over 2 places, so it's 100%. This is actually doubling, DOU. This is doubling every time it goes through this. So that's, as you know, it's an exponential, so that's a very steep growth because it's going up by 100% every time. This one here, so we put the base minus 1, and we get negative 0.5. So it's going down by 50% every time. So this would be a decay, and this is actually similar to a half-life where it's going down by half every time. Okay, so sometimes when we have a problem and we have to find that percent rate of change, we have to find out if it's growth or decay, this is not in the appropriate form. So as you remember from the formula, it's whatever the function is. So in this case, it's R of W, but it could be A of T. The principal amount, 1 plus the rate to the time power. So this one is not just time, it's 1.2 time. So we actually have to make it so that we bring that 1.2 inside. And it's really just all we have to do is 0.89 to the 1.2 power, and we have a W there. So we have to make the base so that this thing is all by itself. So when we do that, remember, don't round until you absolutely have to. So the 620 really has nothing to do with the percent rate of change. That's just the initial amount that you have. But when we do this, 0.86949, whatever, there's lots more. Okay? Don't round it in your calculator until you're done. All right, so then we have to do this, whatever that base is, in your calculator. We subtract our 1, and when we do that, we get negative 0.1305, etc. Move the decimal place over 2, and so 13.1% or negative 13.1% is our rate of change. So that means this is a decay problem. Okay. However, the rate isn't exactly what we thought it would be when we initially looked at it. It looks like it might be 11%, but once we move that 1.2 inside, from out here to inside, it changes the base that we're physically looking at, and it makes it so that we see the actual correct rate of change per week for this problem. So the rest of these, I just put T for time. It could be any amount of time at all, decades, minutes, whatever, it could be anything. But what we have to do is determine the percent rate of change, the correct percent rate of change. So you see this one is T over 2. So I have to realize that T over 2 is equal to 1/2 T. So remember, if it's on the top or the side, it really means the same thing. So that means I have to take this base and raise it to the 1/2 power so that I can get that T all by itself. Okay, when I do that, I get 1.095. Okay, that's what the calculator tells me. I have to take that and subtract my 1. Okay, when I do that, I get 0.0954. It's just basically this. Move it over 2 decimal places, and 9.5% is my percent rate of change. So this one looks like it might be 20%, but it's not. It's 9.5% because we have to see it in the correct form that the formula should be in. So this is still growth, but at a slightly different growth rate than we initially thought. So same thing with all of these. Okay, we have E. Remember, E is just a number, but I have to get it so that it's just whatever this is the base. I have to get that, bring that inside the parentheses basically, and leave the T on the outside. And when I do that, I get 0.135335. I subtract my 1, and I get negative 0.86466, etc. Move it over 2 decimal places, and I get negative 86.5%. So this is definitely decay, and it's a very quick decay because it's going down very fast. So that E is not quite accurate for us for this problem. We do need to bring that decimal in and actually see what the number is. Okay, and then here, same thing. This one is negative. We want, remember, negative 1/3 times T is the same as that. So I have to bring that 1/3 inside. Okay, that 200 really isn't necessary to find the percent rate of change. It's part of the problem, but it's not part of the percent rate of change. So I get 1.1006. I subtract my 1, so I get 1 negative. Oh no, it's positive. Positive 1.006, etc. So moving it over 2, I get 10.1%. And this is a growth. So remember that negative does really change a lot. So it goes from decay. I mean, this looks like it's probably decay because it's less than 1. But then when we raise it to the negative exponent, it will change it to more of a growth problem. Okay? So this is the basic idea, just nitpicking apart the formula and figuring out the percent rate of change. I hope you have a great weekend. Adieu.